Okay, today we're going to be looking at how to solve word problems and find solutions to word problems by writing a system of equations to represent a given situation. All right, here's our first example. All right, nice simple routine problem. Asks us to find the value of two numbers if their sum is 12 and their difference is 4. So we want to write two equations that represent this situation, and we see that the word sum means addition. So if we want to find the value of two numbers that have a sum of 12, I write an equation that says that, right? So we start with x plus y is equal to 12, right? X being one number, y being the second number. Their sum has to be equal to 12. Their difference is 4, right? Differences subtract. So x minus y has to be equal to 4. So there's your system. All right, we can find the solution to this system by adding the two equations to eliminate the y's. So let's eliminate the y's with addition. We add 1x and 1x is 2x. 12 and 4 is 16. Right, we divide both sides of that equation by 2, and we get x is equal to 8. So x represents the first of the two numbers whose sum is 12 and difference is 4. To find the second number, we just replace x in one of the two equations, right, to find y. So we'll replace x in that first equation. So if we replace x with 8 plus y, right, is going to be equal to 12. 8 plus 4 is 12, right? So we know that y is going to be equal to 12. Right, and this is an easy enough one where we could check our solution, right? So is 8 plus 4 12? Yes. Is 8 minus 4 equal to 4? Yes. So we know that 8 and 12 are the two numbers whose sum is 12 and whose difference is 4. Let's take a look at another example. This one's a little bit more complicated. It says the sum of the digits of a certain two-digit number is 7. Reversing its digits increases the number by 9. What's the number? Well, the first equation is pretty simple, right? Because the sum of the digits of a certain two-digit number is 7, right? So we'll have x plus y is equal to 7, right? The sum of the digits, so x and y, right, has to have a sum of 7. But the second sentence is a little tougher. Reversing its digits increases the number by 9. Well, here we have to understand, right? If we have the number, let's say the number is x, y, right? But that x value is actually an x value in the tens digit. So let's say that number might be a 6, right? But that is not just a 6, that is 6 tens. So the value of that 6 in the tens place is actually 60. So when we write our second equation, we have to represent that situation correctly. So our second equation is going to look like the following. 10 times whatever x is plus y, right, because that's our original number, that value increases by 9 when, that's our equal sign, right, when the digits are reversed. So if I reverse the digits, y is now in the tens place, x is now in the ones place. All right, so there's our second system. We want to take our first equation, and I want to rewrite that in terms of either y or x. I'm going to rewrite it in terms of y. So y is going to be equal to 7 minus x. And then I want to use substitution. I want to take that 7 minus x, and wherever I see a y in that second equation, I'm going to replace y with that 7 minus x. So we rewrite, right, and we substitute. So this becomes 10x plus, I'm replacing y with 7 minus x. Then we still have plus 9. That's going to be equal to 10 times. I'm replacing y with 7 minus x. Right? Then we have plus x. Right? We combine our like terms. When we combine our like terms, we wind up with 10x, take away 1x, right? That's 9 x's. Right? I take the 7 and the 9, that's going to be 16. Alright, so we have 9x plus 16, that's going to be equal to, right, we use the distributive property. 10 times 7 is 70, minus 10 times x is 10x, and then we still have plus the 1x. I simplify the right part of this equation, right? So I recopy 9x plus 16. I simplify this, so that's going to be 7. And then we have negative 10x plus 1x. That's going to be minus 9x. So now we have an equation where we have variables on both sides of the equation. We want to remove the variable with the smaller coefficient. Negative 9 is less than positive 9. So we're going to add 9x to both sides of this equation. Right, that gives us 18x plus 16, and that's going to be equal to, right, that eliminates, it's going to be equal to 70. Alright? Okay, so now we have our two-step equation. We're going to subtract 16 from both sides of the equation. Right, that's going to be 0. So now we're left with 18x. It's going to be equal to 70. Take away 16. What's that? 54. Then we divide both sides by 18. Divide by 18. They cancel. And we wind up with x is going to be equal to 3. Now if x is going to be equal to 3, I'm going to take that 3 and I'm going to go all the way back into this original equation all the way up here, and then I'm going to replace x with 3 to find y. So we have 3 plus y is equal to 7, so that means our y is going to be equal to 4. So what is the two-digit number? Well, the x value is 3, the y value is 4, so our two-digit number is 34. Well, let's see if that makes both situations true. Is the sum of 3 and 4 7? Yes. If I reverse the number where we get 43, is 43 an increase of 9 from 34? The answer to that is yes. Alright, so that's a nice example. Alright, let's take a look at the next one. Okay, this one's a bit easier. We have a farmhouse shelters 10 animals. Some are pigs, some are ducks. Although there are 36 legs, or altogether there are 36 legs. How many of each animal are there? Alright, well, if we have a total of 10 animals and they're pigs and ducks, one equation would be pigs plus ducks, right? That's going to be equal to 10. Now, let's assume that the pigs have 4 legs, right? Ducks have 2 legs. So we have 4 legs for each pig plus 2 legs for each duck. Gives you a total of 36 legs. So it's a nice simple system. Let's eliminate the d's. So I'm going to multiply this first equation by negative 2 to eliminate the d's with addition. Right, so that's going to give me negative 2p minus 2d. That's going to be equal to negative 20. And then I recopy the second equation, 4p plus 2d. It's going to be equal to 36. Alright, let's eliminate with addition. We have 2p. They eliminate. That's going to be equal to, what's that, 16. Divide by 2. Divide by 2. Wind up with p is going to be equal to 8. So if we have 8 pigs, I replace p in that first equation with 8. So we have 8 plus the number of ducks is equal to 10. We know that ducks has to be equal to 2. Right, so we have 8 pigs. We'll write that, and we have 2 ducks. Alright, next problem. Flying to Kampala with a tailwind. A plane averaged 158 kilometers an hour. On the return trip, the plane only averaged 112 kilometers per hour while flying back into the same wind. Find the speed of the wind and the speed of the plane in still air. Now, I always like to introduce these types of problems with a basic equation that we're all familiar with. Right? Speed is equal to the distance divided by the time. Right? We all see the signs on the highway. Right? Your speed is equal to 55 miles per hour. Right? So we're used to seeing this equation. Speed is equal to the distance over time. Well, if we rewrite that equation to solve that equation in terms of d, right, I'd multiply both sides of the equation by t, multiply both sides of the equation by t, they cancel, and now we have distance is going to be equal to the speed times the time. And that's the equation we're going to have to use, for these boat problems and these airplane problems, all right? So let's try the airplane problem. Now, we see that speed times time is equal to the distance, right? So let me just reverse that a bit. All right, I'd rather have that written the way we're going to use it. So speed times time is equal to the distance. So the first equation says that the speed plus the wind, this is with the wind, right, is 158 kilometers per hour. Well, this is a measurement of speed, and this is a measurement, of distance, kilometers. This is a measurement of time, hours, right? So my time is going to be 1, because it's 1 hour. The distance is going to be 158 kilometers. So with the tailwind, we're able to go 158 kilometers in an hour. Now against the wind, right, so that would be speed against the wind, so that's S minus W times the 1 hour, we're only able to go 112 kilometers an hour. All right, so now I just want to simplify these two, right? So this becomes S plus W equals 158, and we have S minus W is equal to 112, right? And it's really a nice simple system. We eliminate the W's with addition, wind up with 2S is going to be equal to, what's that, 270. We divide both sides of the equation by 2. They cancel. So the speed of the plane is going to be 135, right? To find the speed of the wind, we're going to take the speed of the plane. We're going to replace S with 135. So we wind up with 135 plus W is going to be equal to 158. Right? We solved that equation for W by subtracting the 135 from both sides of that equation, and we get the speed of the wind is going to be equal to 23 kilometers per hour. All right, so this is our wind speed. We'll write that, right? That's our wind speed, right? And this is our plane speed, right? The airplane speed, right? That's the plane speed. All right, try another one. Right, this is a little bit different because instead of being given the speed as a rate, right, we're given different measurements. We're given a measurement of distance, right, miles. We're given a measurement of time, hours, right. We're told the boat travels 210 miles downstream and back. The trip downstream took 10 hours. The trip back took 70 hours. What is the speed of the boat in still water? What's the speed of the current? Right, but we're going to start with that same equation, right? That the speed plus, what's this, the current, right? So it should be S plus C, because we're talking about current of the river. So the speed plus the current. So if we're going with the current, it only took 10 hours. It took 10 hours to go that 210 miles. But against the current, right, the speed against the current, oops, let's undo that. Right, the speed against the current, that took 70 hours to go the same 210, and these are miles. We want to simplify these a bit, so I'm going to divide both sides here by 10. They cancel, and I get the following equation. S plus C is equal to 21, and simplify this equation by dividing both sides of that equation by 70. They cancel. Right, that divides out, so we get at S minus C is going to be equal to 21 divided by 7. That's going to be 3. So once we do a little preparation, we really get a nice simple system where the C's are going to eliminate with addition. So we wind up with 2S is going to be equal to 24. Divide by 2, divide by 2, they eliminate. We wind up with S is going to be equal to 12. All right. I'm going to replace S with 12 in one of my equations to find the speed of the current. So we wind up with 12 plus C is going to be equal to 21. All right, so I subtract 12, and we wind up with C is going to be equal to 9. All right, so the current is going to be 9 miles per hour, right? So this is the current speed, and then this is the plane speed, or the boat speed of the boat in still water. So these are what? Miles per hour. This is miles per hour. All right, we check it. 12 minus 9 is equal to 3. 12 plus 9 is equal to 21. All right, so that's going to work for us. Let's look at our next example. The State Fair is a popular field trip destination. This year, the senior class at High School A and the senior class at High School B both planned trips there. The senior class at High School A rented and filled 8 vans and 8 buses with 240 students. High School B rented and filled 4 vans and 1 bus with 54 students. Every van had the same number of students in it as did the buses. Find the number of students in each van and in each bus. All right. Well, I want to take, I guess, this situation here and write an equation that represents that. So that's going to be 8V plus 8B. It's going to be equal to 240. And then I want to take, let's see, this situation here, write an equation that represents that. So we have 4V plus 1B. That's going to be equal to 54. Now we can eliminate, let's see, if I multiply this second equation by -2, it looks like we'd be able to eliminate the V's with addition. So I'm going to recopy the first equation. 8V plus 8B is going to be equal to 240. That's not going to change. But then this equation here, that's going to be -8V. And then this is going to be minus 2B. That's going to be equal to -108. Right? The V's are going to eliminate with addition. So I add 8B and -2B. That's going to be 6B is equal to, what's that? 132. We divide both sides of that equation by 6. And we wind up with B is going to be equal to 22. So that's the number of students on each bus. And if I want to find the number of students, let's see, in each van, right, I'm going to replace B, right, with in one of the equations, and it looks like that second equation would be a little bit easier to replace B because there's only one of them, and that'll allow us to find V. So we have 4 V's plus the 22 that we just replaced the 1B with. That's going to be equal to 54. Nice simple two-step equation. Subtract 22, subtract 22. They cancel, so we're left with 4V is going to be equal to 32. Divide by 4, they cancel, so V is going to be equal to 8. So that's the number of students in each van is going to be 8, and the number of students in each bus is going to be 22. All right, another type of system problem. All right, next, the ratio problem. Right, we have attendance at a concert was 480. The ratio of adults to students was 5:3. How many adults attended? How many students attended? All right, well, the first equation is rather simple, right? Because we have adults and students total 480, right? So that's rather simple. But the second system is a little tougher, and we have to write it carefully. The ratio of adults to students. So I would write adults to students as a ratio. So that's as a fraction. Adults is the top of the ratio, students is in the bottom. All right, so that ratio was 5:3. So there's my second equation. It's actually a proportion, 2 equal ratios. Now, what we want to do is to solve that equation for either A or S, and then replace whichever variable in the first equation. So we do that by first finding the cross products, or using the cross products property, which says that the cross products of equivalent ratios are equal. So I multiply 3 times A, which is going to give me 3A, I multiply s times 5, that's going to give me 5s. Well, let's solve this equation for a. So I divide both sides of that equation by 3, and we wind up with a is going to be equal to 5/3 s. And now I want to find, alright, now we want to use substitution. I'm going to replace a in that first equation with 5/3 s. So now we have 5/3 s plus 1s is equal to 480. Well, what's 5/3 plus 1s? Well, we have to find common or use common denominator, so s, if I'm writing it as 1, is really 3/3. So I have 5/3 plus 3/3, which is the same as 1, gives me 8/3 s is equal to 480. So I want to solve that equation by dividing both sides by 8/3. Divide by 8/3, they cancel. So s is going to be equal to 480 times 3/8 when we multiply by the reciprocal. Alright, divide out, that becomes 1, that becomes 60. We multiply numerator times numerator, denominator times denominator, and we wind up with s is going to be equal to 60 times 3, that's 180. So now that we know the number of students that attended, the concert was 180, I simply want to bring that up here to find the a, the number of adults. Alright, so a plus 180 is equal to 480, and if we solve that for a, we'd subtract 180 from both sides of the equation. That becomes 0, and we get the number of adults is equal to 480 minus 180 is 300. So we have 300 adults, we have 180 students, and we've answered the question, right? So we have 300 adults attended the concert. Adults, we have 180 students. Students attended the concert as well. Alright? Alright, we continue. The money problem. Okay, you have money, you have a money jar containing nickels and quarters worth $1.55. The money jar contains 11 coins. How many of each coin do you have? Well, the first equation's not too difficult, right? Because we know that we have nickels plus quarters totals 11, right? Nickels and quarters, we have a total of 11 coins. But we also know that you get 5 cents, right, for every nickel, plus we have 25 cents for every quarter, and that gives you $1.55. Now, rather than work with these decimal quantities, we're going to first multiply this equation by 100, right, so that we get rid of the decimals. So 5/100 times 100, that's going to be 5n. Plus, multiply this by 100, that's going to be 25q. That's going to be equal to 155. And then we have the n plus the q is equal to 11. Now, if we want to eliminate, right, I'm going to take this equation here, right, this equation, and I'm going to multiply that equation by, let's do -5, so that we can eliminate with addition. So that top equation becomes the following: -5n, what's that, minus 5q, that's going to be equal to -55. I'm going to recopy this bottom equation, which is 5n plus 25q, that's going to be equal to 155. Now we can eliminate the n's with addition, so they're gone. This gives you what? -5q plus 25q, that's 20q, is equal to -55 and 155, that's 100. When we solve for q, we're going to divide both sides by 20. They cancel. Q's going to be equal to 5. Once I know q is 5, it's pretty easy to find the number of nickels. So I'm going to go back to that original equation and replace q with 5. So we have n plus 5 is going to be equal to 11. Right, to solve for n, we're going to subtract 5 from both sides of that equation, and we wind up with the number of nickels is going to be equal to 6. So we have 6 nickels, we have 5 quarters. Alright? Okay, let's see what we have here. Ronaldo and Brooke are picking up trash along the highway. Together, they've collected 15 bags of trash. Brooke has collected 3 more bags than Ronaldo. How many bags has each collected? Alright, now we're just trying to represent this situation with a system. Alright, well, together they've collected 15 bags of trash. So Ronaldo plus Brooke is 15. But then the second equation is a little bit more involved, right? It says Brooke has collected, so Brooke has collected 3 more bags than Ronaldo. So Brooke is equal to Ronaldo plus 3. Alright, I want to replace B with R plus 3. So that gives you the following. R plus R plus 3. That's going to be equal to 15. R plus R gives you 2R. Plus 3 is going to be 15. Two-step equation. Subtract 3 from both sides of that equation. We wind up with 2R is going to be equal to 12. Divide by 2. Divide by 2. They cancel. R is going to be equal to 6. Alright, and once I know R is 6, I'm going to replace R with 6 to find B. So I have 6 plus B is equal to 15. Alright, so that means B has to be 9. Right, B has to be equal to 9. So, how many bags has each collected? Brooke has 9 bags. Ronaldo has 6 bags. Alright. Okay, I think this is the last of our systems problems, right? And this is what's called the break-even problem. And when we have the break-even problem, we have to understand that in order for a company to break even, right, the costs has to be the same as the income, right, in order for a company to break even. Right, so let's read the problem. A toy manufacturing company makes a doll that sells for $12. It costs $5 in labor to make each doll. The total cost for the materials is $420. How many dolls must they sell to break even? So your costs are, right, your cost equation, your costs are Y is equal to $5 for each doll plus the 400 and, oops, 420 that's supposed to be, right, plus the 420. Your income, Y is equal to $12 for each doll. And we want to set your costs and income equivalent to each other. So we write the following equation. 5x plus 420 is going to be the same as 12x. Your costs equal your income. And then it's a nice simple equation that we solve. We have variables on both sides of the equal sign. We solve this equation by removing the variable with the smaller coefficient. We wind up with 420 is going to be equal to 7x. Divide by 7, divide by 7. We wind up with 60 is equal to x. So how many dolls must be sold to break even? Right, that's got to be 60 dolls. Alright, so we spent some time going through many different types of systems problems, right? And that's 10 examples. I think we did 10 different types of systems or types of problems that we can use systems to find solutions for. And I'm sure there are many more, but these are, you know, a good solid start. Alright, so I hope that's helpful to you guys, and we'll see you soon.